All right, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 3, Lesson number 4. I kind of replaced this with Lesson 4. This is, we're going to deal with discriminates with quadratic formula and also finding the actual solutions themselves, because I believe in the last one we were actually finding discriminates, and now we're going to see how it's all put together. Warm up here for, this is Lesson 4's warm up probably, replaced it. We're converting some units, so yard squared into feet squared. Now think of a yard squared, there's, if you think of a yard, there are 3 feet in a yard. But if you're talking about square, you're talking about a square of 3 feet by 3 feet, which 3 times 3 would make 9 feet squared equals 1 yard. So if you've got 7 yards squared, 7 times 9, and each one of these yard squares has 9 feet squared, so that would be 63 feet squared. Same thing going from feet to inches. Now, there are 12 inches in a foot, which means a 12 by 12 square would be 144. So if there's 144 inches squared and 1 foot squared, I'm going to multiply that by 5, and that means that there are 720 inches squared. All right, 1 mile. Now, I believe there's 5,380. I could be wrong on that. Hopefully not. 5,280 maybe. I think that's what it is. 5,280. Multiply that by itself, 5,280. And that's going to give you a lot. Okay, so that's a lot of feet squared. So that's 27,878,400. I use, like I said, I used 5,280. If it's 380, I'm just thinking the wrong number. You might just have to check yourself. 100 meters squared, well, you know there's 100 centimeters in 1 meter. So 100 by 100 would be 10,000. So there's 10,000 centimeters squared in 1 meter squared. And then I'm going to multiply that by 100. Well, I don't even need to use a calculator, so that's going to give me 1 million. Exactly. All right. And the next one. So we're going from feet squared to yard squared. Okay, so we're going from a smaller unit into a larger unit. Okay, so there's 9 of these for every one of these. So I'm going to divide this time. I'm going to divide 300 of them, because it takes 9 of them to make 1 yard squared, and it looks like it's going to make 33 1/3 yards squared. This was centimeters squared. Oh, don't forget my units. This is also going from a smaller unit into a bigger unit, so the number's going to get smaller. Now remember, there are 12 by 12 square would be 144 inches squared and 1 foot squared. So this is actually less than 1 foot squared. 96 divided by the 144 needed would tell you that it's going to be 2/3 of a foot squared. All right, so like I said before, this video is going to be more about finding, using that discriminant to determine how many solutions it has and actually finding the solutions themselves, because the last video was just finding the discriminant itself. So this is what it would look like after you find the discriminant. So let's say the discriminant was 36. Now, if it is 36, then we know that the square root of 36 is 6. That's going to be 10 plus or minus 6 over 8. So then what you would do then is simplify it by solving it twice. Do 10 plus 6 and 10 minus 6 over 8, and then that's going to give you your 2 solutions. All right, so this one, if it was 360, I believe I changed this one to 361, because if I'm not mistaken, 19 squared is 361. Just double check that. Yes, it is. So that's going to be 14 plus or minus 19 over 8. So I just changed this problem up here to make it work out perfectly. Another perfect square. So if the discriminant is 100, that means the square root of 100 would be 10. So that would become 8 plus or minus 10 over 16. And then you can solve it twice, which I'm going to do on the next step, but I don't want to take too long in this video because I want to get to the next page. Now, what makes these problems different down here is you're going to get square root of 98. Now, you're going to notice that all of these all have discriminants that are not perfect squares. So what I would do is I would just round this. Now, I don't have a calculator on me that's going to do that for me because I'm just using my phone calculator. But I would put square root of 98. So what you do on a graphic calculator is press second and then square root button, which I believe is the 5th button down on the far left-hand side. And then put 98 and press enter. Then I would normally round it to the nearest 10th. Now, I know this is going to be 9 point something. I'm pretty sure this is 9.9, so I would change that to 7 plus or minus 9.9 over 7. Now I can solve it twice using addition and subtraction. Now, square root of 54. I do know that this is slightly more than 7 because 54 is more than 49. 49 is a perfect square of 7, and an 8 perfect square would be 64. So this is 10 away from 64, but it's only 5 away from 49. So I know it's going to be 7 point something, and it's going to be closer to 7 than it's going to be 8. So it's probably going to be about 7.3, 7.4 in that neighborhood. So then I would change that. I'm just going to guess that it was 7.3. I'm not quite sure. I don't have the calculator. 200, and I can do the same thing for that one too, but I'm just going to skip and go straight to here. Now, first thing you're going to notice when you look at these problems here, 4, 5, and 6, is that they're not set equal to 0. So that is actually your first step. You want to make it set it equal to 0. A in this case is 2, B is 5, but C is actually positive 3 because this is on the wrong side. I would have to add 3 to both sides. So question number 5, this is 2. This is going to be positive 1 for B and negative 6 for C. This one's going to be 3 for A and negative 2 for B and negative 5 for C. That one was already set equal to 0. Now I'm ready to plug things into the quadratic formula, which is negative B plus or minus the square root of B squared minus 4AC divided by 2A. All right, negative B. So in this case, B was 5. Remember, negative B means the opposite of B. So if B was a negative to begin with, it becomes a positive. So that becomes negative 5 plus or minus the square root of B squared, which is 5 squared minus 4 times A, which is 2, times C, which is 3. All of that divided by 2 times A, which is 2. Negative 5 plus or minus square root. Now I'm going to simplify the discriminant. 5 squared becomes 25. And negative 4 times 2 is negative 8, times 3 is negative 24. So it looks like we got a discriminant of 1. Now that's a great discriminant because the square root of 1 is 1. That's negative 5 plus or minus 1 over 4. Now I'm ready to solve it twice. I'm going to do negative 5 plus 1 over 4 and negative 5 minus 1 over 4. Well, negative 5 plus 1 makes negative 4, and negative 4 divided by 4 is negative 1. There's one of your answers. X can equal negative 1. Negative 5 minus 1 makes negative 6. Negative 6 divided by 4 is negative 1.5. So X can also equal negative 1.5. There are your two answers to this equation. Remember, it had two answers because the discriminant was a positive number. It was 1, a matter of fact. All right, I'm going to skip 2 because I kind of took away some of the room here. I'm going to go to 6 and do that problem. All right, so this time the B is negative. Remember what I said earlier. So if the B is negative, the opposite of that number is positive 2, plus or minus square root of negative 2 squared minus 4. Now you notice I put in parentheses this time because it's a negative, and when you put it in the calculator, you got to make sure you put those parentheses. Otherwise, it's not going to think it's negative 2 squared, but the opposite of 2 squared. Negative 4 times A times C, which is negative 5. All that divided by 2 times 3. All right, 2 plus or minus square root of. We've got negative 2 squared, which is 4. Negative 4 times 3 is negative 12, and negative 12 times negative 5 is positive 60. It looks like we've got another good discriminant because the discriminant is 64, and that is a perfect square of 8. So it's going to be 2 plus or minus 8 over 6. So I'm going to solve it twice. I'm going to do 2 plus 8 over 6, and I'm also going to do 2 minus 8 over 6. That's 10. 10 divided by 6, 1 4/10, so that's going to be 1.4. And 2 minus 8 is negative 6 divided by 6 is negative 1. There's your two answers. Great. All right, so we've done an example of not only having to set it equal to 0, but then we substituted it into the equation, and then we simplified the discriminant, and we solved our two answers at the end. So we did a lot there. That's basically putting everything together using the quadratic formula. Now I do have a couple of more examples, and I'm going to do one more of these, and I do want to save some time to do the homework. This one, I will show you the A, B, and C. So A is negative 2. Ooh, that was a tricky one. Okay, this is on the wrong side. I want to set it equal to 0. I got to move it to the other side, change it to the opposite. This becomes 6, and this becomes 9. All right, over here, it looks like we have A is 1, and B is negative 2, and C is 5. That one was pretty easy. It was already set equal to 0. All right, so negative B, so that's 2 plus or minus square root of negative 2 squared minus 4 times 1 times 5, which is the C. All that divided by 2 times a, which is 1. All right, 2 plus or minus. Negative 2 squared is 4. Negative 4 times 1 is negative 4 times 20 is negative 20. Now, it looks like in this question we're going to get a negative discriminant, which means if we're getting a negative discriminant, then it's going to have no solutions. Okay, so I'm glad we did an example of this so we can see that this is what happens when you have a negative discriminant. It's going to have no solutions. It's like a graph, a quadratic, where it never hits the x-axis. So therefore it has no answers because it has no x-intercepts. All right, so getting to that homework. There's 3 graphs here, 3 quadratics. Start with x squared. So this is 0, 0. It's going to be up 1, then up 4, then up 9. You can put this in the graphing calculator. It'll tell you all the numbers I'm coming up with. It's going to look like this, and the same thing on the other side. All right, so that's x squared, and then x squared minus 9 will look exactly the same as the parent function. Only difference is it's going to be lower. It's going to be translated 9 units down. You might remember that when you did vertex form, because this really is the same thing as x minus 0 squared, like vertex form, with the minus 9 is the k on the outside, which means it slid 9 units down. But then you've got this x plus 2, and you remember back in the vertex form, because that's really what this is, x plus 2 actually makes it slide 2 units to the left. So this parabola is going to look the same shape as the other 3, only it's been slid down 9 and left 2, because remember what's in the parentheses is always the opposite. How do g and x and h of x compare to each other? I believe I already answered most of these questions. So they have the same shape, but it's been translated 2 to the left. What are the x-intercepts of g of x? Oh, I would need to actually solve that. I don't have the graphing calculator on me. G of x, when does that hit the x-axis? When it has a y of 0. So what I can do here is set it equal to 0. 0 equals x squared minus 9. And that is a perfect square. That is the differences of squares. Sorry, 0 equals... That's going to be an x minus 3 times x plus 3 squared. I'm going to use zero product property, and it looks like the answers are 3 and negative 3. It'd been a lot easier if I could just put that in the graphing calculator and look at the table and see that it has 2 zeros at 3 and negative 3. How do the x-intercepts in g of x, this one, relate to the x-intercepts in each of the other functions, and how do they compare? So this one has an x, this only has one answer at 0. This one has 2 answers at 3 and negative 3. This one, I assume it has 2 answers, but I'm not exactly sure what it's going to be. It's going to be slid a little bit over to the left. So actually, I'm assuming since it's 1, how much was it moved? 2 to the left. So I'm assuming the answers are just shifted over 2 to the left as well. So let me just double check that theory. So if this was 3 here, and I'm assuming that this would have been 1, which doesn't seem, okay, so maybe I made it a little bit too wide. So if I put 1 in here for x, well, that equals 0. 1 plus 2 is 3. 3 squared is 9. 9 minus 9 is 0. So yes, so it looks like, as I just stated, it looks like the answers are going to be 1 and negative 5. Now, how did I do that? Because like I said, if this has been translated to the left, then the answers have been translated to the left as well, because the parabola has exactly the same shape. Now, basically, everything I just said is what I would put right here. I'm just going to scribble a bunch of information because I basically told you what the answer was. All right. Please give it a like if I helped you learn something about solving using the quadratic formula. And subscribe if you haven't done so already. Have a wonderful day.